Welcome to episode 1 of AI Practitioner Exam Bites. Today we're going to cover the first two exam objectives in Domain 1, Fundamentals of AI and ML. Task Statement 1.1, Explain basic AI concepts and terminologies. And they are: define basic AI terms, for example, AI, ML, deep learning, neural networks, computer vision, natural language processing, NLP, model, algorithm, training and inferencing, bias, fairness, fit, large language model, LLM. Phew. And if that wasn't enough, we're also going to describe the similarities and differences between AI, ML, and deep learning. Let's start at the beginning with what is artificial intelligence. Well, AI involves simulating human intelligence and decision making by building algorithms, which essentially are computer programs, to take and process information which informs future decisions. You could build a simple AI through manually defining or hand coding a series of rules, but there are issues with this approach, like ensuring that you include rules to cover all situations and also the need to constantly update these rules. So wouldn't it be great if you could instead provide a computer with some sample data, tell it the correct result for each piece of data, and it could automatically derive the rules to reach those results? Well, that's called machine learning because, well, the machine is learning. And ML is probably the most common type of AI, and it's a subset of AI. Let's look at how machine learning or ML works. Sample data is fed into the machine, or the machine learning algorithm, I should say. Now, this machine learning algorithm is a computer program that's designed to identify patterns in a set of data. It then derives the rules based on those identified patterns, a process known as training, and produces what we call a machine learning model. We can then present new unseen data to this machine learning model, and it will provide a prediction on the result, a process known as inferencing. Let's do a quick example. You want to build a machine learning model to predict house prices based on the location, the land size, and number of bedrooms. You'll provide sample data, this is called training data, with maybe a few thousand homes, specifying their location, size, number of bedrooms, along with their price. The machine learning algorithm would look at this data and automatically derive a set of rules, which then forms the machine learning model. You can then present this model with new input data, in this case, a combination of location, size, and number of bedrooms, which it hasn't previously seen in training, and it would use the rules it's derived to predict the price of that house. If the model can accurately predict house prices for a range of homes, it is likely because it has captured the underlying patterns in the training data, so we would say the model is a good fit. It's also important to ensure the model is not biased, such as if the model consistently undervalued homes in a neighbourhood due to, say, historical data showing lower prices in that area, even if the current market conditions reflect more favourable prices. Finally, fairness is also critical to ensure the model makes accurate predictions, for example, across all demographic groups, avoiding outcomes that could lead to unequal treatment or discrimination. Now, that was a very simple example. What if we need to do something more complex, like a computer vision problem, which involves making decisions on visual data, or perhaps natural language processing, which involves computers comprehending and interpreting human language? This is where a subset of machine learning comes into play, called deep learning, or we can just abbreviate it as DL for short. This is really important for problems involving complex, unstructured data like images and text. Artificial neural networks are the backbone of deep learning and are computational models inspired by the human brain and can automatically recognize patterns in complex datasets. A common and well-known use of deep learning and artificial neural networks are for large language models, or LLMs, which is a deep learning model that can understand and generate human language. We'll be talking more about LLMs later in this series. Now, over to you. Here's a quick review question. Which of the following best describes machine learning, or ML? Is it A, building algorithms to simulate human intelligence? B, building a model without the need for sample data? C, simulating human intelligence by processing information manually? Or D, using algorithms to identify patterns in data and automatically derive rules? Post your answer in the comments and I'll give you the correct answer in tomorrow's video, where we're going to be talking about all the different types of inferencing. Bye for now.